back to the course on blockchain architecture. So, we were discussing about several research aspects in blockchain in terms of protocol and consensus scalability. So, that today we will discuss a very interesting topic which is floating for the last 1 year in the community, in the blockchain community, and it claims to have a nice and scalable consensus architecture over blockchain, and accordingly proposes a new cryptocurrency. So, the idea is to have a new cryptocurrency called Algorand, which came from MIT Artificial Intelligence and Computer Science Laboratory, and a paper called Algorand Scaling Byzantine Agreement for Cryptocurrencies. The paper got published in last year ACM SOSP conference. So, we will discuss about this topic in details, and there is Algorand website, and the code for Algorand is also available publicly. So, you can explore it further by browsing through the Algorand website. So, let us go through the journey of Algorand. So, this concept of cryptocurrencies, it started from Bitcoin, and then we have seen a series of different cryptocurrencies starting from Bitcoin to Ethereum, then Ripple, then Zcash, and finally this Algorand. And as this different kind of cryptocurrency progress, they have kind of nice properties, and people have thought of to improving different aspects like scalability, consensus finality, and security over the existing cryptocurrencies protocol, and that way we have seen the evaluation of multiple cryptocurrencies which came into practice. So, let us look into the problems of Bitcoin which was there, and why or what is the basic motivation behind the design of a new cryptocurrency, and then we will go to the basic features of algorithm and discuss algorithm and architecture of Algorand in a higher level. So, I will not go to the very intrinsic details of the cryptographic protocols and the mathematical proofs of Algorand. I will try to motivate you about the nice concepts and highlight the innovations which are there in the design of Algorand. So, let us look into a brief overview of Bitcoin. So, the key idea of Bitcoin is the consensus through proof of work. So, Bitcoin employs this proof of work mechanism to reach consensus, where the communication is through gossiping. So, every node in a Bitcoin network, they gossip with each other for the transactions as well as the blocks, and that way they try to reach in a consensus cryptographic consensus and adding a block to the existing blockchain. And the key assumption in the Bitcoin proof of work design is that the honest majority of the mining computation power. So, it is like that the mining computation power is distributed among multiple miners, and that way at different round of Bitcoin, different miner will win, and they will work as a leader to propose a new block. So, that way the idea is that based on the proof of work mechanism, at a single round a new miner will be get elected, and that miner will propose the new block, and that way we will have different miners at different rounds. So, no one will be able to control the entire network single handedly. So, from there we move towards the technical limitations of Bitcoin. So, there are multiple limitations which have been there in the Bitcoin architecture. So, the first problem in Bitcoin which has been well explored in the existing literature is the resource wastage problem. So, whenever you are utilizing this mining procedure to add a new block in the existing blockchain, you require a high computation power to solve the hash problem which is associated with the Bitcoin proof of work mechanism. So, as a result, you require a huge amount of computation power to search for the nonce value which will produce the intended hash, and as a result we have seen that many people or all the miners are actually trying to mine a new block, but only one or a very few of them will win to mine a new block. And as a result, the total wastage of power is significantly higher. So, you have requirement of this high computational power and the electricity cost, which is associated with the Bitcoin protocol. Then another limitation of Bitcoin is the concentration of the mining power. So, we have discussed about this concept of mining pools, and with the concept of mining pools we have seen that only around 5 mining pools, they basically control the entire system. And interestingly, you know that who are those mining pools and where those mining pools are actually belong. So, as a result, you can always track that where are those mining pools, and it is easy to abrupt or to corrupt those mining pool or to take a control of those mining pools. So, vulnerability becomes higher whenever you know that who the miner is and who are actually controlling the entire mining procedure. So, if you just go to this blockchain.org website, and there you can see that this entire block generation mechanism of Bitcoin mining that is being controlled by around 5 or 6 different mining pools. So, that concept of mining pool, although it help people to join in a mining pool and then participate in the mining procedure, but it is also one of the biggest threat in the sustainability of Bitcoin proof of work. Then as I have mentioned that the entire architecture is vulnerable because it is easy to track miners whenever you have some handful number of mining pools. The next problem that we discussed earlier, that the scalability is a major issue in block Bitcoin. So, there are two types of scalability: the scalability in terms of number of nodes or number of users that can be supported, and the scalability in terms of transaction throughput. So, we have already seen that scalability in terms of transaction throughput is very limited. In case of Bitcoin, you can almost have around 7 to 9 transactions per second. On the other hand, it is not very clear that how many number of simultaneous users can be supported in Bitcoin. So, whether it is 1 million or 10 million or 100 million, so the limitation is not known. And because of this high latency, which is approximately 10 minutes for committing a new block, your transaction throughput is very less. And then another major problem in Bitcoin is this consensus finality. So, absence of consensus finality, which leads to ambiguity. So, there is always a possibility of fork, and whenever there is a possibility of fork, you have multiple different paths in the block in the blockchain, and as a result you do not know that which path is the current accepted path. So, Bitcoin normally utilize this 50% rule, where if you get multiple copies of the current blockchain from your peers, and all the, or say you are receiving 2 different copies of the blockchain from your peers, and both the copies have say equal chain length. In that case, you will accept the blockchain which is coming from majority of your peers. So, there is this ambiguity, but because of this ambiguity or because of this fork, and there is no such consensus finality, there is always a possibility of wastage of resources. So, these orphan blocks are actually wasting a number of handful of resources for the miners, because the miners are actually mining that block, but ultimately those particular block, although it is getting a valid block, but that block is not included in the longest chain of the blockchain, which is there in the Bitcoin blockchain. So, these are the major technical limitations which are there in Bitcoin, and with this limitation we give you a brief overview of Algorand. So, the key idea is Algorand. Key idea of Algorand is consensus through Byzantine agreement protocol based on the Byzantine fault tolerance that we have discussed earlier. The communication is again gossiping, and the key assumption is the honest majority of money. So, that you can find out that who the peer is, and you can find out the valid peers who are there in the system. So, these are the technical advancement of algorithm in comparison with the existing cryptocurrency like Bitcoin. So, first of all, the operations which are introduced in Algorand, they are very trivial, simple operations like adds or counts. So, we do not have operations or costly operations like finding out the nonce to compute a target hash value, which actually results in a huge wastage of computational resource and mining power. And it provides a true decentralization, which is in contrast to the mining pool concept which is there in Bitcoin. So, there is no concentration of mining pool power, all are equal miners and there is equal users. So, anyone in Algorand they can join in the mining procedure. So, as such Algorand does not call it as a mining because we are using the concept of this Byzantine agreement here and as a result any user who is participating in the Algorand network they can mine a new block and because the operations are very trivial and very simple anyone can join and you do not require a complex mechanism or a complex system or a resourceful system to participate in the mining procedure. Then there is this finality of the payment. So, in Algorand you can have a fork with very low probability. So, the probability is around 1 by 10 to the power 18. So, which is a very small number. Now, because of this finality of the payment, the block which appears in a blockchain and you have certain transactions in that particular block, if the block is get added in the blockchain, so the transaction which is there inside the block they are final, which is in contrast to Bitcoin. In case of Bitcoin, even if a block is getting added to the blockchain, you do not know whether that block is going to be an orphan block in the future time instance or not, which is not there in Algorand because of this consensus finality. Then the concept of scalability. So, Algorand can support millions of users and the delay of block commitment is only equal to the network latency. So, network latency is a kind of bottleneck which is there. So, if you have a good network, you can have a quick consensus protocol. So, approximately in a general network it is close to around 1 minute and then it provides a strong security. So, the security against bad adversaries. So, let us look into the security perspective of Algorand. So, it avoids Sybil's attack. So, as we have discussed earlier in Sybil attacks, the adversary creates many pseudonyms to influence the Byzantine agreement protocol. So, Algorand is free from this kind of Sybil attacks and it is also resilient from denial of service attacks. So, it can operate even if an adversary disconnects some of the users from the Algorand network. Well, so now let us look at how the protocol actually works in practice. So, there are primarily two different steps in Algorand. So, assume that you have millions of users. So, what we do that in the first round similar to Bitcoin, this entire Algorand protocol works in rounds and at every round at the end of a round block is getting added in the existing blockchain. So, at the beginning of a round the first task is to select a random user among the set of users who are participating in the Algorand procedure. So, this random user prepares a block and propagate the block through gossiping. So, any of the users they can collect the transactions and after collecting the transactions they can propose a new block. Now, the node or the user who is going to propose a new block that is being selected by a nice algorithm called cryptographic sortation. We will come to that point, but the idea is that you are randomly selecting an user who will propose the block. Now, that particular user which you are selecting for proposal of a new block, that user may be a valid user or that user may be an adversary. So, we require a kind of Byzantine agreement protocol to find out that whether the block which is being proposed by the user by the random user whether it is a valid block or not. So, for that we again select a random committee with a small number of users. Now, here is the catch. So, if you remember the traditional Byzantine agreement protocols, this Byzantine agreement protocol like the Byzantine fault tolerant, even with practical Byzantine fault tolerant, they have overhead. So, they are not scalable in terms of number of nodes. So, what we are doing here in case of Algorand, not all the users in the network, they are participating in the committee for participating in the Byzantine agreement protocol. Rather, we are selecting a small committee, and that small committee will execute the Byzantine agreement, and that way it will make the entire system scalable. So, the idea here is that you select a random committee with a small number of users who will run the Byzantine agreement on the block. Now, if they find out that the block is nice, the block is correct, then they will digitally sign the result and propagate this digital signature in the network. Now, assume that you are in the network, you are in the Algorand network, and you have heard a new block which is been proposed by a particular miner or a particular user, Algorand user. Now, whenever after receiving that block, if you are waiting, say you are waiting for the digital signatures corresponds to block which are supposed to be coming from the committee members. Now, if you are receiving some number of signatures more than certain threshold, then you are sure that this particular block has been signed or this particular block has been agreed upon by that many number of committee members, which means that the block is actually a correct block. So, you can connect this correct block to the existing blockchain. So, that way this entire architecture becomes very scalable. Now, there is an interesting question that who will select the committee, because if you have a node who is going to select the committee, the adversary can control that node, and that way we can control the entire network. And remember that Algorand actually targets not a permission model, rather it is considering a permissionless model. That means it is an open model where anyone can join in the network. Now, whenever you are in a permissionless model, you cannot have a single node or a single god who will select the committee. So, the question comes, who will select the committee, and that is another interesting concept in Algorand, that each committee member select himself according to per user weights. So, the idea is that we have certain magic which will select every user or every user can elect himself as a part of the committee. So, it is just like a lottery kind of algorithm. You are running a lottery. If you are winning the lottery, then you have a proof that you have won the lottery, and you can show that proof and participate in the committee. Now, this particular concept is very interesting in the context of scalability. The idea here is that we do not have any distributed algorithm or decentralized algorithm that is actually electing a committee. So, the committee members are electing themselves. So, as a result, what is happening here, that the individual committee members, they will just run certain local computations in their own machine and find out whether they are winning that lottery or not. If they are winning that lottery, they can participate in the committee and participate in validating that particular block which has been proposed in the current round. Now, at every different round, we design this election procedure, or we design this lottery mechanism in such a way, so that at every individual round different members are elected as a part of the committee. Now, if different members are elected as a part of the committee at different round, then the interesting fact is that the adversary will not be able to take control of the committee members. So, that concept is used in Algorand. So, we actually realized this particular concept with the help of something called verifiable random functions or VRFs. So, this is a cryptographic sortation mechanism where every committee member, they are individually selecting themselves. So, they are running a lottery protocol through which they will find out whether they are winning the lottery or not, and if they are winning the lottery, they will show a proof. Now, what is a verifiable random function? So, this verifiable random function takes two parameters. There is an input string and there is a public private key pair. So, you have a public key called pki and a private key pair at ski for round I. Now, you are generating this verifiable random function with this private key pair. So, this private key is with every individual user. So, no one will be able to tamper the user. Now, once this VRF function is executed, then it generates two parameters, one hash and one proof. So, this hash is a hash-length bit long value that is uniquely determined by sk and x. So, with the value of hash, you can uniquely identify a particular user, and then there is a proof. This particular proof, if someone has the public key pki, then they can check whether the hash indeed corresponds to x. So, if the hash is indeed corresponds to x, that means this particular proof will say that well, the user who is claiming to be the leader in the current round, then that particular member, the committee member has actually executed the protocol correctly, execute this VRF correctly, and has a proof that he or she has won in the current round. So, that way this verifiable random function gives a nice architecture of this entire procedure. So, we are not going to the formal proof of VRF. So, if you are interested, you can dig into more details inside VRF. Well, so this is the cryptographic sortition procedure which is used in member selection. The committee member selection is Algorand. So, it takes some parameters, the sk value, a seed value, that particular seed value is generated based on the current round number. So, this seed value actually ensures that at every different round, different sets of members are being elected as a part of the committee. So, that way at every individual rounds the committee member gets changed, and because the committee members gets changed at every individual round, the adversary has no way to control the committee members. You put a value, threshold value, the role of the users in terms of proposing a new block, that means the initial random users which we are going to select, or whether the user is going to be a committee member. Then W is the weight of a user, and capital W is the weight of all the users in the network. So, here this weight values comes from the factors like how much money the individual users have. That way, the idea is there that this will give a weight to individual users to be elected as a committee member or to be elected as a user to proposing a new block, and J is the value like the user gets to participate as different sub users. So, this returns this tree value has proof along with this J. So, this entire procedure works in this way. So, once you have this hash and the proof value, you make a gossiping among the peers in the network, and you can show the proof that you have won the current round, and that way you can be a member for the committee of the current round, or you have the power to propose a new block. Well, now every user, every other user in the peer, they can verify this sortition procedure with the help of the public key pk. So, you can find out that whether this particular user has actually won the lottery and got the power to be a member of the committee or got the power to propose a new block. So, you can check if the user was selected. So, this particular function, it returns the number of selected sub users. This number actually determines that what would be the number of members in the committee, and interestingly at different round there are different number of members who can be part of the committee, and this number actually determines that well, these are the members of the committee, and if these are the members of the committee, say if you are getting there are j number of members in the committee, then how many votes you are expecting to prove that a particular proposed block is a valid block. So, if you are getting that many number of votes based on the Byzantine agreement protocol, then you are sure that well this particular block is getting added to the existing blockchain, and you can add that block with the blockchain. And this function verify short, it will return 0 if the user was not selected at all. Well, so the seed selection procedure in cryptographic sortition is something like this, and this seed selection procedure ensures that well at different rounds different set of members will be there for validating the block in the committee, and this particular round number determines who will be the members of that committee. And remember that at different rounds different number of members can be there in the committee. This seed it is published at Algorand's round R using this verifiable random function with the seed of the previous round R minus 1. So, Algorand reaches agreement on the block for round R minus 1 once everyone computes the seed at the start of round R. So, once round R minus 1 is over, then everyone starts computing the seed value for round R. Now, the seed 0 it is chosen at random by initial participant with the help of a verifiable random function. So, we are using this verifiable random function for the seed generation itself, and to limit the adversary's ability to selection of the seed value. So, the seed value is refreshed at every R round, capital R round. Okay. So, fine. Next come the block proposal. So, once you are elected as a node for proposing a new block, now there is a catch here that because every member is electing himself or herself for proposing a new block at an instance of time or at a single round, it may be possible that there are multiple users who are proposing a new block. So, if there are multiple users who are proposing a new block, then we require this agreement protocol to reach into a consensus that which block to accept for. Now, to minimize the unnecessary block transmission, Algorand apply a mechanism. So, it discard the messages not having the highest priority seen by that user so far. So, we define a priority mechanism based on this hashing of the hash output of the VRF, and it is concatenated with the sub user index. So, the hash value and the sub user index together it provides a priority value, and the user who has the highest priority that block is being propagated further in the network. So, what you are doing, if you have elected yourself and if you have won the current round for the proposal of a new block, then you wait for certain amount of time to see that whether any other block is coming or not. So, you wait for this much number of time, which is lambda step variable plus lambda priority, where lambda step variable is the variance in how long it takes different users to finish the last step of the Byzantine agreement, and lambda priority is the time taken to gossip the priority and approve message, and the total time is approximately 10 seconds. So, you wait for approximately 10 seconds to see whether a new block is coming or not. If a new block is coming, then you see whether your block or your priority is more than the priority of the current block or not. If your priority is more than the priority of the current block, then you propagate your new block. Otherwise, you do not propagate the block any further. So, that way you can minimize unnecessary block transmission in the network. Then once the block transmission is done, then we run the Byzantine agreement protocol. So, this Byzantine agreement protocol it works in two phases. The first phase, in the first phase it reduces the problem of agreeing on a block to agreement on one of the two options. So, in Algorand mechanism, we can have either a final consensus or we can have a tentative consensus. So, today we will stop here up to this point, that we have selected or we have proposed a new block. So, we have elected a member among the set of users for the proposal of a new block. So, say the block got propagated in the network. Now, there are two conditions, either the block is coming from a valid user. If the block is coming from a valid user, then you have to ensure that the block is coming from a valid user, and you need to reach in an agreement that this particular block can be added to the blockchain. Otherwise, if multiple users are proposing the block simultaneously, then you have to show that which particular block need to be added based on the priority to by checking the priority value. So, that way this Algorand consensus, it adds up a particular block in the existing blockchain. So, this works on this Byzantine agreement protocol, and Byzantine agreement protocol in blockchain, interestingly it provides two type of consensus. One is called the final consensus, another is called the tentative consensus. So, today we will stop here, and in the next class we will discuss about this concept of final consensus and tentative consensus, and we will see that how Byzantine agreement protocol actually helps in reach into the consensus even in the presence of adversary in the network. So, thank you all for attending this class today.